welcome to my channel. So in the today's lecture, we are going to discuss one example of deadlock. Okay, so before watching this video, watch my last video of deadlock. I will mention the link in the description box. Okay, so what is my problem? My problem is I have 5 processes. Okay, I have 5 processes. Each process request for 3 resources. Okay, if you are going to execute any process, your process demand 3 resources. Okay, you have to allocate 3 resources for the successful execution of the process. Okay, so my question is, what should be the maximum number of resources for deadlock to occur? Okay, what we want deadlock to occur. Okay, we want deadlock. We intentionally want deadlock. Okay, so what should be the maximum number of resources with the help of which deadlock situation might occur? Okay, each process needs 3 resources. If I allocate each process 2 resources, okay, 1 resource less than its demand, okay, 1 resource less than its demand, then deadlock problem might occur like this. I am assigning each process 1 resource less than its requirement. Okay, like this. Let's suppose I have resource R. Okay, I have 1 resource R and I have multiple copies of it. Okay, let's suppose I have multiple copies of this resource R. Okay, so what is the maximum number of resources are going to be there if we want deadlock to occur? 2 plus 2 plus 2 plus 2 plus 2. It is equal to 10. Okay, so each and every process require 3 resources. Okay, the requirement of one process is to get 3 resources. Okay, if I allocate all of the 3 resources to your one process, then you are not getting deadlock. Okay, but I want to stuck each and every process at some point. Okay, I don't want any process to complete its execution. I want each and every process to stuck at some point so that no process can proceed further. Okay, I intentionally want to stuck each and every process at some point of time. Okay, so if we want deadlock to occur, the maximum resources we should have is actually 10. Okay, let's suppose I am having this resource R. I am having 10 copies of it. Okay, if you assign resources like this to 5 processes, like this. Okay, each and every process has acquired 2 resources. Okay, now if you add 1 more resource, okay, if you now try to add 1 more resource here, then we don't have deadlock problem. Okay, because this process is going to complete its execution, then it is going to release all of its 3 resources, then all these 4 remaining processes get going to occur when all of your processes are going to stuck if each and every process has acquired two resources each. Okay, now this is the maximum number of resources, okay, which is required for deadlock to occur. If you have less than 10 resources, if you have 6, 8, 7, 9, then there is also a chance of deadlock. But what is my question? My question is, what is the maximum number of resources for deadlock to occur? Okay, so 10 is going to be my maximum number of resources for deadlock condition. Okay, I hope that you are clear with this example. How we solve such kind of problem? You assign one resource less than the requirement of the process. Okay, all these 5 processes need 3 resources each, but I am assigning all these processes one resource less than their requirement. Okay, so this is actually your maximum number of resources for deadlock to occur. Okay, so this is my first question. So what is my next question? We have to find the minimum number of resources, okay, so that deadlock doesn't occur. We don't want any deadlock now. Okay, we want to avoid deadlock. Okay, if you want to avoid deadlock, if you don't want any deadlock, then what should be the minimum resources you should have? Okay, if you have these resources, if you have 11 resources, okay, you try any way, you assign your resources to all these 5 processes in any manner. Anyhow, okay, you will not get deadlock. Okay, because there is one process which is going to acquire all of the 3 resources. Okay, once your process P1 has been completely executed, it is going to release all of its 3 resources. Okay, then we will give all these 3 released resources to all these 4 processes so that they can complete their execution. Okay, so what is the minimum number of resources required so that we can avoid deadlock? 10 plus 1. Okay, the maximum number of resources for deadlock to occur, we have is 10 plus 1. We have a minimum number of resources to avoid the deadlock. Okay, if you use any resources more than 11, 11 is the minimum number of resources to avoid the deadlock. Okay, you use any number more than 11, 12, 13, 14, okay, you use any number, you will not get deadlock. This 11 is the minimum number of resources required to avoid the deadlock. Okay, if you have 10 resources, okay, if you have 10 resources, it is not sure that you will get the deadlock. There is also a chance that you might not get deadlock. Okay, what can be the possible condition if you want to avoid deadlock? Even if you have 10 resources, still there is a chance that you might not get deadlock. If you are assigning resources to all of your processes like this, okay, you can avoid the deadlock. But we are just trying to assume the condition. We are trying to assume each and every possible condition. Okay, this is one possibility that you might not get deadlock with 10 resources. but you are not always sure. Okay, there is definitely a little bit chance that with the help of 10 resources, you might get deadlock. So, 10 is the maximum number of resources for deadlock to occur. Okay, if you add one more resource to it, you can avoid the deadlock. Okay, so I hope that you are clear with this example. If you liked my video, please like, share and subscribe my channel.